As you settle into stillness, let your breath slow and your body soften beneath the weight of the evening. In this gentle hour, as the outer world begins to hush, we turn inward toward a quieter landscape, one that hums softly and ceaselessly within us. Tonight, we will explore the immune system, not as a battleground or in the language of conflict, but as a quiet network of care, an ever watchful, ever adaptive guardian that stands watch over you, even in sleep. The immune system is one of the most intricate and elegant features of the human body. Unlike an organ you can point to like the heart or lungs, the immune system is everywhere and nowhere, all at once. It is not housed in a single location, but rather dispersed across tissues, cells, and secretions, working in harmony. Its components travel fluidly, circulating through the bloodstream, dwelling in quiet tissues, waiting at the surface of the skin, and lying just beneath every mucosal lining. Its task is both profound and perpetual. The immune system's purpose is to recognize what is self, your body, your cells, your unique biology, and what is not. It identifies substances that do not belong, from tiny particles of pollen to complex, living microorganisms like bacteria or viruses. Then, it determines what to do. Most of the time, it makes these decisions in the background of your awareness, without fuss, without pause. Imagine it as a kind of silent orchestra, a symphony of cells and signals, fluids and feedback loops, that together create harmony in your internal environment. When you brush up against the outer world through touch, breath, or ingestion, this system takes note, not with fear, but with care. And if it senses something amiss, it responds not in panic, but with thoughtful coordination. This system does not sleep. While you rest, its work continues, quietly, in the folds of your lungs, where air meets blood. It monitors for unfamiliar particles. In your gut, where trillions of microbes mingle with your cells, it maintains a delicate balance. Beneath your skin, sentinel cells await, just beneath the surface, tuned to the smallest changes in your tissue. All the while, a fluid called lymph weaves its way through vessels and nodes, carrying messages, waste, and immune cells on their silent errands. The immune system can be divided into two overarching branches, the innate and the adaptive. Though we'll explore them more fully in time, for now, it's enough to say that the innate immune system is your body's first responder. It acts quickly, broadly, and with simple but effective tools. The adaptive immune system, by contrast, learns. It remembers. Over time, it becomes more tailored and precise, crafting responses to particular microbes based on past encounters. Together, these systems form a layered and evolving defense, one that matures as you do. But to think of the immune system only as a shield is to miss its deeper truth. It is also a mediator. It guides healing, clears debris, and even communicates with other systems like the brain and gut. When a cut on your finger begins to close, that is the immune system at work. When a fever rises and falls, that too is a signal, not of damage, but of regulation, a carefully controlled process meant to protect and restore. There is great beauty in this quiet resilience, and it begins early. Even before birth, the foundations of immunity are laid down. A baby receives antibodies from the mother first through the placenta, and then through milk, which offer a borrowed protection, a kind of temporary wisdom until the child's own immune system matures. Over the first years of life, this system grows and learns, adapting to the world it encounters, building its library of responses. Later in life, the immune system continues to evolve. With age, it becomes more selective, sometimes less robust, but no less vital. Certain parts may slow, but others become more refined. Throughout all stages of life, it remains a constant companion shaping your ability to heal, to adapt, and to remain in balance with the world around you. As we prepare to explore each part of this system in more detail, let this be your gentle foundation. The immune system is not a wall or a weapon. It is a garden complex, interwoven and alive. A place where defense and nourishment coexist, where recognition leads to wisdom, and where, even in the stillness of sleep, there is presence and protection. So as you rest, know that within you, an ancient and elegant process is unfolding quietly, faithfully, without need of praise or notice. The immune system, your inner sentinel, is watching over you now. 2. The essence of immunity. Let your breath continue its slow rhythm. With each gentle rise and fall, feel your body resting more deeply into stillness. We now drift further into the soft workings of the immune system, not just its parts, but its purpose. What does it mean, truly, to have immunity? At its heart, immunity is the body's ability to recognize and respond to what is foreign, while preserving what is self. It is not about force, but about discernment. To be immune is not to be impervious, but to be adaptable. Immune function is a kind of conversation between your body and the world, a dialogue that unfolds quietly and continually. In its earliest form, immunity is inherited. You are born with innate immunity, the biological equivalent of ancestral wisdom. These defenses do not require memory or training. They are built in. Skin forms a physical boundary. Secretions like tears and saliva contain enzymes that dissolve potential invaders. Deep within tissues, immune cells lie ready to engulf and neutralize any substance that does not belong. This innate system is broad in scope. It reacts the same way each time it encounters a potential threat. Like a vigilant night watchman, it does not pause to ask detailed questions, but responds quickly and effectively to keep the peace. Its tools include phagocytes, which engulf intruders, and natural killer cells, which quietly seek out cells that seem altered or unwell. But the body also possesses a second layer, one that learns, adapts, and remembers. This is the adaptive immune system. Unlike its innate counterpart, it is highly specific. Adaptive immunity is what enables your body to remember a virus you encountered years ago, or to build long-term protection after a vaccination. It is a slower responder, but more refined, capable of tailoring responses to the unique structure of a pathogen. At the center of this adaptive system are lymphocytes, most notably T cells and B cells. These cells are like scholars, studying the structure of foreign molecules called antigens and devising targeted ways to neutralize or eliminate them. Some T cells directly attack infected cells. Others help orchestrate the broader response. B cells, in turn, produce antibodies, small, Y-shaped proteins that float freely in the bloodstream and bind precisely to antigens, marking them for removal. The wonder of this system is not just in its precision, but in its memory. Once the adaptive immune system has responded to a particular pathogen, it stores the knowledge. Memory cells remain in the body, sometimes for years, ready to respond more quickly if the same invader ever returns. This is why many illnesses like chickenpox usually occur only once. The immune system does not forget. Immunity, then, is not static. It is a dynamic state of balance, constantly responding to shifting environments. It is shaped by genetics, influenced by experience, and supported by rest, nourishment, and time. Every encounter with the outside world, from a new food, to a passing cold, to a breath of spring air, provides information. And the immune system listens, carefully cataloging, learning what to accept and what to keep at bay. Interestingly, immunity is not only about resisting harm, It also plays a role in tolerance, the ability to recognize when something foreign is actually benign. This is how the body can host trillions of microbes in the gut without launching an immune attack. It learns to identify friendly bacteria and coexist with them. A well-regulated immune system is not aggressive but discerning. In this light, we begin to see the immune system not as a shield, but as a sensorium, a network of perception. It does not simply defend, it interprets. It makes decisions about what is safe, what is unfamiliar, and what requires action. And sometimes, it decides to let something pass in peace. When this system functions well, we are often unaware of it. Cuts heal, colds resolve, infections are cleared. But like all complex systems, it depends on balance. When underactive, we become vulnerable to illness. When overactive, the immune system may begin to misidentify harmless substances as threats, as in allergies, or even mistake the body's own tissues as foreign, leading to autoimmune conditions. These are reminders of the system's deep sensitivity and the care with which it operates. Your immune system is not a single army, but a network dispersed across organs, cells, and fluids. It involves the bone marrow, where immune cells are born, the thymus, where T cells mature, the lymph nodes, which filter lymph fluid and trap foreign particles, and the spleen, which helps detect blood-borne pathogens and removes old red blood cells. It also relies on signaling molecules called cytokines and chemokines, which act as messengers between cells. These molecules guide cells to sites of injury, inflammation, or infection. They regulate the intensity of immune responses and help resolve them once the work is done. In a sense, the immune system mirrors the rhythms of life itself, alert and adaptive, cautious yet open, protective yet capable of trust. It teaches us that health is not the absence of challenge, but the presence of harmony. And so, as your breath remains soft and your body settles further, you might begin to sense this gentle rhythm within, the slow turning of cells, the quiet exchange of signals, the wise memory of antibodies, all of it working in the background, holding space for healing, for restoration, and for peace. Even now, as your mind prepares for rest, your immune system continues its quiet work, attentive, precise, and profoundly kind. 3. Innate versus adaptive immunity. As the stillness of evening deepens, let your thoughts slow with it, like leaves drifting gently downstream. Tonight we continue our journey inward to explore the two great branches of the immune system, the innate and the adaptive. These twin systems, distinct in their tools and timing, together form the quiet foundation of your body's protection and resilience. The innate immune system is your body's first line of defense. It is the more ancient of the two systems, a deep-rooted inheritance that exists in some form across nearly all living organisms. From the simplest sea sponge to the complexity of the human body, innate immunity stands as an immediate and broad-acting guardian. Imagine a well-worn trail through a quiet forest. It does not matter who walks along it. The same wind rustles the trees. The same leaves fall in their soft spirals. So too, the innate immune system responds in largely the same way to any perceived intruder. It does not recognize specific pathogens, but rather general patterns, chemical or structural features that are commonly found on viruses, bacteria, or injured cells. These are known as pathogen-associated molecular patterns, or PAMPs. The cells of the innate system are quick to act. Among the most important are the phagocytes, a name that means eating cells. These include macrophages, which patrol tissues and engulf foreign material, and neutrophils, fast-moving cells that arrive swiftly at the site of injury or infection. Once engaged, these cells envelop invaders, break them down, and signal to other immune players that help is needed. There are also natural killer cells, which roam the body looking for cells that seem off balance, such as virus-infected or cancerous cells. Rather than waiting for a precise diagnosis, they act decisively, removing the risk before it grows. Though blunt in their approach, they are essential to maintaining early control over threats. Alongside these cells, the innate immune system deploys chemical signals, such as cytokines, that amplify the immune response and help recruit additional defenses. It also activates the complement system, a network of proteins that circulate in the blood, marking invaders for destruction, creating small pores in bacterial membranes, and promoting inflammation. The beauty of the innate system is its speed. Within minutes of a breach, whether a cut on the skin or an inhaled particle, it responds. The blood vessels near the site may widen, drawing more immune cells into the area. Fluids may accumulate, diluting toxins. The skin may warm slightly, or redden, gentle signs that your body is responding, not in alarm, but in purpose. Still, the innate system is limited in one key way. It does not learn. It treats every new encounter with the same strategy. It does not remember past infections, nor does it improve with experience. That role belongs to the other branch, the adaptive immune system. The adaptive system is more recent in evolutionary terms and more refined in its behavior. Where the innate system is broad and quick, the adaptive system is precise and deliberate. It can take days to activate, but once engaged, it brings a level of specificity and memory that no innate cell can match. At the heart of adaptive immunity are two types of lymphocytes, T cells and B cells. These are not generalists. Each cell is designed to recognize a particular antigen, a molecule, or fragment from a specific pathogen. This level of targeting is remarkable. It's as though each cell carries a unique key, waiting for the moment it meets its matching lock. When a B cell encounters its corresponding antigen, often with the help of a helper T cell, it begins to produce antibodies, proteins that float freely in the blood and lymph, binding to that antigen wherever it appears. These antibodies neutralize pathogens directly, mark them for destruction by other cells, and prevent viruses from entering healthy cells. T cells, meanwhile, come in several forms. Some are helper T cells, which coordinate the immune response by releasing cytokines and activating other immune cells. Others are cytotoxic T cells, which directly destroy infected or abnormal cells, such as those harboring a virus. Each response is measured, calculated, and specific. One of the most profound features of adaptive immunity is its memory. After an infection is cleared, the immune system does not simply forget. Instead, it retains memory B cells and memory T cells, long-lived cells that remain dormant but vigilant. If the same pathogen ever returns, these memory cells respond far more quickly and robustly. Often they neutralize the invader before symptoms even appear. This is the principle behind vaccination, introducing a harmless version or fragment of a pathogen to train the adaptive system. It allows the body to build a memory without needing to experience the illness itself. A quiet rehearsal, so to speak, for a performance that may never come. Despite their differences, these two systems, innate and adaptive, are deeply interconnected. The innate system does not simply act and step aside. It informs and guides the adaptive system, often by presenting antigens to T cells and B cells. Certain cells, like dendritic cells, serve as a bridge, gathering information from the front lines and delivering it to the adaptive system, like a message in a sealed envelope. Together, these systems create a layered defense, one that is swift, smart, and always evolving. Each day, as you go about your quiet routines, the innate system stands at the threshold, responding to the unexpected. And just beyond, the adaptive system waits in readiness, a quiet library of experience, full of encoded memories that protect you again and again. As you lie in stillness now, your body is not idle. Deep within your tissues, cells of the innate system continue their rounds, while memory cells of the adaptive system hold space for tomorrow's needs. There is harmony in this division of labor, not a battle, but a balance, not fear, but quiet vigilance. Let your body rest into this gentle trust that within you, both ancient reflexes and learned wisdom are at work. The immune system is not one thing, it is many things, moving together, slowly, silently, while you sleep. 4. Physical and chemical barriers. Let the stillness of your body deepen now, as we turn our attention to the outermost layers of defense, the parts of the immune system you can almost touch, and yet rarely notice. These are the physical and chemical barriers, the quiet sentinels that guard the thresholds of your body. Before any immune cell is called to action, before any antibody is formed, the body relies on its surfaces, skin, mucous membranes, and secretions to form a gentle but persistent shield against the outer world. These surfaces are not passive walls. They are dynamic landscapes, alive with activity and tailored to their specific environments. Begin with the skin, the most visible barrier and the largest organ of your body. It stretches over you like a protective sheath, forming a boundary between what is self and what is not. It is waterproof, slightly acidic, and constantly renewing. The outermost layer, the stratum corneum, is composed of dead, flattened cells, rich in keratin, a protein that resists breakdown. These cells are tightly packed, creating a surface that is not easily breached. Beneath this lies living skin, layered with immune cells, tiny glands, and sensory receptors. As sweat evaporates, it cools the body, but it also contains antimicrobial peptides, small molecules that disrupt bacterial membranes. The oil secreted by sebaceous glands, known as sebum, adds another layer of defense. Slightly acidic, it creates an environment that discourages microbial growth. Together, sweat and oil help maintain a skin pH of around 5.5, just acidic enough to deter many pathogens. Even when the skin is unbroken, it is active. Immune cells such as Langerhans cells reside just beneath the surface, quietly monitoring for intruders. Should the skin be pierced by a splinter or a scrape, these cells are among the first to alert deeper immune components. They serve as lookouts, passing messages inward through a network of immune signals. But not all surfaces are dry and external. The body's inner linings, known as mucous membranes, protect the respiratory tract, digestive system, reproductive organs, and more. These moist surfaces are more vulnerable to microbial invasion, yet they too are equipped with specialized defenses. Consider the nose and throat entry points for the air we breathe. The nasal passages are lined with cilia, tiny hair-like structures that move in synchronized waves. As you inhale, these cilia trap and sweep away dust, pollen, and microbes, coating them in mucus, a thick fluid rich in enzymes and antibodies. This mucus contains lysozyme, an enzyme that breaks down bacterial cell walls, as well as immunoglobulin A, IEA, an antibody that neutralizes pathogens before they can penetrate deeper. With each breath, a gentle cleansing occurs, like the tide washing a quiet shore. Farther down, the lungs are also lined with mucus and cilia. This mucociliary escalator, as it is sometimes called, moves debris upward toward the throat, where it can be swallowed or expelled. It is one of the body's simplest and most effective self-cleaning systems, a gentle elevator that runs without rest. The digestive tract, though teeming with beneficial microbes, also relies on physical and chemical barriers. The mouth begins this process with saliva, a mixture of water, enzymes, and antimicrobial molecules. As food travels to the stomach, it encounters a much more aggressive environment. Here, gastric acid, primarily hydrochloric acid, creates a pH as low as 1.5, enough to destroy most ingested microbes. Even so, some pathogens survive this acidic bath. That is why the gut is lined with epithelial cells closely joined together, forming a nearly impermeable wall. These cells secrete mucus, just as in the airways, and are supported by immune cells embedded within the lining. Beneath this layer lies a vast network known as the gut-associated lymphoid tissue, GALT, a dense collection of immune cells that watch over this busy, microbe-filled environment with care. The urinary tract, too, has its barriers. Its linings are regularly flushed by urine, which is slightly acidic and contains substances that discourage microbial attachment. The constant flow helps to remove potential invaders before they can settle. The eyes are similarly protected. Blinking distributes a thin film of tears across the surface, which contain both lysozyme and other antimicrobial agents. Should a particle or microbe land on the eye, the tear film helps to trap and flush it away. Even the ears contribute, secreting cerumen, or earwax, which contains compounds that fight bacteria and trap dust or debris. The reproductive tract also possesses its own tailored defenses. In the vagina, a slightly acidic environment is maintained by the presence of beneficial bacteria, such as lactobacillus, which produce lactic acid. This helps prevent the growth of harmful organisms. Mucus secretions provide both lubrication and protection, and are enriched with immune molecules that vary subtly throughout the menstrual cycle. What unites all these barriers from skin to stomach, from lungs to tears, is their preventive nature. They are designed not to fight once illness has taken hold, but to stop it from ever gaining entry. In this way, they reduce the burden on deeper immune components, allowing the rest of the system to remain in quiet balance. It is easy to overlook these first lines of defense. They act without notice, respond without recognition, and renew themselves without fanfare. And yet, they are essential to health. They are the peaceful border guards, the gatekeepers of harmony. As your breath deepens and your awareness turns inward once more, you might imagine this outer shell of protection not as a rigid wall, but as a dynamic surface, alive with renewal and care. It wraps you in quiet vigilance, sensing the world, adapting gently, and holding space for safety. Long before illness has a chance to form, these gentle barriers have already done their part. And as you sleep, they will continue layer by layer, cell by cell, to preserve the inner stillness of your body. 5. Cells of the innate immune system. As your body rests deeper into the quiet of the night, we now drift gently toward the cellular realm, the silent responders of your innate immune system. These are the cells that awaken first when something unfamiliar crosses the body's outer defenses. Their movements are steady and unhurried, their purpose clear. The innate immune system acts without memory. It does not ask for history, nor does it wait for instruction. It simply responds broadly, effectively, and without delay. Its cells are like watchful stewards scattered throughout the body, ever present, ever attuned to patterns that do not belong. Among the most central of these are the phagocytes, a word that means eating cells. These cells move through tissues and bloodstream alike, seeking out signs of injury or invasion. When they find what they're looking for, they envelop the foreign matter and quietly dismantle it. It is a process that has protected life for hundreds of millions of years. One of the key phagocytes is the macrophage. Derived from Greek roots meaning big eater, the macrophage is a large, versatile cell. It resides in almost every tissue of the body and serves not only as a frontline defender, but also as a cleaner, removing dead cells and cellular debris. When a macrophage detects a microbe, it engulfs it into a specialized compartment within itself, then uses enzymes to break it down. Macrophages are also great communicators. After digesting an intruder, they display fragments of it on their surface, a process known as antigen presentation. This signal, though part of the innate system, becomes the bridge to the adaptive immune system, helping T cells recognize threats with greater precision. In this way, macrophages not only respond in the moment, but also lay the groundwork for longer-term defense. Alongside macrophages are the neutrophils' smaller, faster phagocytes that circulate in the blood in large numbers. Neutrophils are among the first cells to arrive at a site of injury or infection. They are drawn there by chemical signals released by damaged tissues or resident immune cells. Once they arrive, they engulf bacteria or fungi and release enzymes that break down invaders. Neutrophils are swift but short-lived. After completing their task, they often self-destruct, forming part of the soft, cloudy material we know as pus. Their passing is not in vain. By sacrificing themselves, they remove danger and pave the way for healing. Another notable cell of innate immunity is the dendritic cell. While its name may suggest a tree, it is named for its branched shape, thin, reaching projections that increase surface area and allow it to interact with many cells at once. Dendritic cells are found in tissues that are in contact with the external environment, such as the skin, the lining of the nose, and the lungs. Like macrophages, dendritic cells ingest foreign particles and present them to the adaptive immune system. They are messengers between realms innate and adaptive, ensuring that no intrusion goes unnoticed by the body's deeper defenses. In a different role altogether are the natural killer cells, or NK cells. These are lymphocytes, like T and B cells, but they do not require prior exposure to a pathogen. Instead, they scan the surfaces of cells for signs of abnormality. A healthy cell carries certain identifying molecules on its surface. If these are missing or altered, as can happen in cells infected by viruses or transformed by cancer, the NK cell takes action. With quiet precision, natural killer cells release enzymes that induce programmed cell death, a process called apoptosis. It is not violent, but measured. The affected cell is dismantled from within and absorbed by neighboring cells, or phagocytes, with minimal inflammation. In this way, NK cells maintain the body's internal order, removing the unwell before they can disrupt the whole. Then there are mast cells, stationed primarily in the skin, lungs, and digestive tract. These cells are filled with granules, tiny packets containing histamine and other chemical mediators. When triggered, mast cells release these substances, increasing blood flow, alerting nearby immune cells, and making the surrounding tissues more permeable to incoming defenders. Though mast cells are best known for their role in allergic reactions, they are also early responders to injury and infection, helping to coordinate the broader immune response. Basophils and eosinophils are two other cell types in the innate immune family. Both circulate in the blood and are involved in responses to parasites and allergens. Eosinophils are especially active in combating multicellular invaders like worms, rare in many parts of the modern world, but once common enough to shape much of our immune evolution. Basophils, like mast cells, contain histamine and help orchestrate inflammatory responses, particularly in allergic conditions. Each of these cells has a distinct role. Some ingest, some alert, some destroy, and others communicate. But all share a common mission: to maintain the integrity of the body's internal environment, responding swiftly and effectively to whatever might threaten it. Importantly, the cells of the innate system are pre-programmed. Their receptors, known as pattern recognition receptors, recognize general danger signals, not specific invaders. These receptors are tuned to detect conserved molecular features of pathogens, such as bacterial cell wall components or viral RNA. One group of these receptors, called toll-like receptors, or TLRs, is especially well studied. TLRs are found on the surface of many innate immune cells. When triggered, they initiate a cascade of signals within the cell, prompting it to produce cytokines, summon other immune cells, and shift into an active state. Yet, even as these defenses activate, they remain controlled. The body carefully regulates how and when these cells respond. Too much inflammation, or activity in the wrong context, can be as damaging as the threat itself. Thus, the innate system is as much about restraint as it is about readiness. As your body lies still, the cells of your innate immune system are quietly circulating. Some drift through the bloodstream like sentinels on patrol. Others reside in the tissues, waiting patiently for a signal. All are connected through chemical messages, woven together by ancient, invisible threads. You may never feel their presence, but they are there beneath the skin, within the blood, across the lungs and gut, keeping gentle watch, responding when needed, and retreating when peace is restored. And as you rest, this quiet choreography continues a dance of vigilance, unfolding cell by cell, moment by moment, while you sleep. 6. The inflammatory response. As your breath deepens and your limbs grow heavy with stillness, we now enter one of the body's most essential and often misunderstood processes: inflammation. In the quiet domain of immune function, inflammation is not chaos, but communication. It is not destruction, but direction. It is the body's ancient signal, a call to restore order, to bring healing where balance has been disturbed. At its core, the inflammatory response is a protective process. It is initiated whenever tissue is damaged by injury, infection, heat, or chemical irritants. The moment something breaches the integrity of the skin or internal lining, the body sends a signal: something is not quite right here, and in reply, the immune system mobilizes. Inflammation begins not with pain, but with recognition. Resident cells, such as mast cells and macrophages, detect distress. These cells are stationed within the tissue's quiet watchers, attuned to change. Upon sensing injury or infection, they release chemical messengers called cytokines and chemokines. These molecules ripple outward, like sound waves in water, alerting neighboring cells and drawing immune reinforcements from the bloodstream. One of the first responses is vasodilation, the widening of nearby blood vessels. This allows more blood to flow into the affected area, bringing with it oxygen, nutrients, clotting factors, and white blood cells. As these vessels widen, their walls also become more permeable, allowing immune cells and fluid to pass through and enter the tissue. This gentle flood of blood and fluid is what creates the familiar signs of inflammation: redness from increased blood flow, swelling from fluid accumulation, warmth as heated blood fills the tissue, and sometimes tenderness as nerve endings become activated. Though these sensations can be uncomfortable, they are not inherently harmful. They are signs that healing has begun. The first immune cells to arrive are usually neutrophils, swift and efficient phagocytes that engulf pathogens and cellular debris. Their presence is temporary, but powerful. They clear away intruders and send further signals to sustain the response. Behind them come the monocytes, which mature into macrophages upon entering the tissue. These macrophages take over cleanup duties and begin to assess the damage, preparing the tissue for repair. If the invader is microbial, a virus, bacterium, or fungus, then antigen-presenting cells, like dendritic cells and macrophages, begin to collect fragments of the pathogen. These fragments, known as antigens, are carried to nearby lymph nodes, where the adaptive immune system is invited to participate. In this way, inflammation is not an isolated act, but a coordinated message, a hand extended from one branch of immunity to another. As the inflammation continues, platelets assist in clotting and sealing the wound. Fibroblasts begin laying down connective tissue. Dead cells are cleared away. Gradually, As the threat subsides, the same immune cells that initiated inflammation now begin to resolve it. Specialized cytokines are released, telling the immune system that its work is nearly done. Repair replaces response. Calm is restored. Inflammation, then, is not only the body's first aid system, it is also a kind of conversation, a coordinated effort to detect trouble, to respond proportionally, and to step back when the work is complete. It is temporary by design. When regulated, it is a source of healing. Yet, like all complex systems, inflammation requires balance. If the inflammatory response is too weak, injuries may linger and infections may spread. If it is too strong, the surrounding healthy tissues may be harmed in the crossfire. And if it is prolonged, it may become chronic, a persistent simmer that can wear down tissues over time. Chronic inflammation differs from the acute, short-term response we've just described. Instead of arising quickly and resolving within days, it lingers often subtly, quietly affecting joints, blood vessels, or internal organs. It may be triggered by an unresolved infection, an autoimmune reaction, or ongoing exposure to irritants such as pollutants or certain foods. Though it moves slowly, it can erode the body's natural rhythms. But even here, in its imperfect forms, inflammation reflects the body's deep intention to protect. When dysregulated, it is not acting out of malice, but from a misreading of signals, as if trying to solve a problem that no longer exists, or reacting to a whisper as though it were a shout. Fortunately, the body is also equipped with mechanisms to counterbalance inflammation. One such regulator is the class of immune cells known as regulatory T cells, which help dial down immune activity once a threat has been neutralized. There are also anti-inflammatory cytokines, such as interleukin-10 and transforming growth factor beta, which signal to immune cells that it is time to rest, to repair, to be still once again. In daily life, the inflammatory response is always close at hand, though often unnoticed. It is there when a scraped knee becomes pink and tender. It is there when a sore throat signals your body's defense against a virus. And it is there, subtly, in the background, each time your body clears away a minor irritation before it ever reaches your awareness. As you lie here now, the processes of inflammation may be unfolding in small and gentle ways, perhaps in a healing cut or a minor irritation you didn't even notice. Within you, vessels may be gently dilating. Cells may be signaling, responding, resolving. All of this is happening without disruption to your rest. It is a sign not of disturbance, but of restoration. Inflammation is not your enemy. It is your ally, a language your body uses to heal itself, a whisper of activity beneath the surface, reminding us that even pain, when guided wisely, can be a step toward wholeness. So let this be your quiet understanding tonight. The warmth of healing, the redness of renewal, the swelling that signals attention, these are not signs of failure. They are the body's way of tending to itself. Inflammation is the breath of the immune system rising when needed, and falling away when the work is done. And as you sleep, your body listens. It responds, adjusts, and repairs always, with the goal of returning you to balance, to stillness, to peace. 7. The lymphatic system's quiet role. Let your body soften once more, like a feather resting on still water in the gentle world of immunity. Not all defenders shout or strike. Some are quiet facilitators moving unseen, transporting signals, filtering waste, and maintaining the delicate equilibrium that defines health. One such system flows beside your bloodstream, slower and softer, yet no less vital. This is the lymphatic system, the immune system's quiet current. The lymphatic system is a network of vessels, nodes, and organs that supports immune function in subtle and essential ways. It is often overlooked, but it is always active, gathering fluid, removing impurities, and hosting crucial moments of immune communication. Like a shadow to the circulatory system, it winds through your body, tracing a parallel path with its own gentle rhythm. At its core, the lymphatic system carries a pale, translucent fluid known as lymph. This fluid begins as a simple seepage plasma that has left the blood vessels to bathe the tissues, delivering oxygen and nutrients. Once it completes that journey, much of the fluid returns to the blood, but some of it, along with proteins, waste products, and occasional stray cells, is collected by tiny lymphatic capillaries. These capillaries form the starting point of the lymphatic system. They are small, delicate vessels with walls just permeable enough to allow the fluid to enter. Once inside, the fluid is now called lymph, and it begins its slow passage through larger and larger lymphatic vessels, eventually making its way toward the thoracic duct, a central channel that empties the filtered lymph back into the bloodstream near the heart. Unlike the blood, lymph does not flow with the force of a pump. The lymphatic system has no central heart. Instead, it relies on the movement of muscles, the pulsation of nearby arteries, and the gentle pressure of breathing to propel its contents. Inside the vessels, a series of valves ensures that the lymph flows in only one direction, slowly, steadily, toward its eventual return. As lymph travels, it passes through small checkpoints known as lymph nodes. These nodes are scattered throughout the body, clustered in the neck, under the arms, along the jaw, in the abdomen, and near the groin. Each lymph node is like a quiet, self-contained outpost, a place where immune cells gather, rest, and inspect the contents of the lymph. Inside the nodes, macrophages and dendritic cells act as guardians and analysts. They sift through the lymph, looking for antigens, fragments of viruses, bacteria, or abnormal cells. If something concerning is found, these cells can sound a soft internal alarm, calling in T cells and B cells to begin an adaptive immune response. The structure of a lymph node reflects its purpose. Surrounded by a fibrous capsule, it contains separate zones for different types of immune cells. In the outer cortex, B cells cluster and await instruction. In the paracortex, T cells dwell and communicate with dendritic cells. Deeper still, the medulla hosts plasma cells, mature B cells that produce antibodies and release them into circulation. While many lymph nodes work independently, they also communicate with one another. If one node detects a threat, others may respond in kind. This networked vigilance ensures that infections or abnormalities are noticed quickly, even if they begin far from the center of the body. Beyond the nodes and vessels, the lymphatic system includes several organs that contribute to immune function. One is the spleen, tucked quietly beneath the ribcage on the left side of the body. Though often associated with blood, the spleen is also a major player in immune surveillance. It filters the blood, removing old red blood cells and scanning for signs of infection. Within its white pulp, immune cells gather and respond to antigens that arrive through the bloodstream. Another key structure is the thymus, nestled just behind the sternum. It is most active in early life, gradually shrinking with age. Here, T cells mature and are trained to distinguish between self and non-self, a critical skill that prevents the immune system from turning against its own body. Though small and fleeting in the arc of a life, the thymus shapes much of the immune system's wisdom. Also part of this quiet system are the tonsils and adenoids, located near the entrance of the throat and nasal cavity. These lymphoid tissues are among the first to encounter airborne or ingested pathogens. They are especially active in childhood, helping to build immune familiarity with the world. Even the bone marrow, where most immune cells are born, can be considered a part of this broader lymphatic support structure. It is from here that B cells emerge and begin their roles in antibody production, and from here that all blood and immune lineages arise. Together, the vessels, nodes, and organs of the lymphatic system do not attack or destroy. Instead, they transport, filter, and coordinate. They are the quiet couriers of immunity, carrying the whispers of danger and the instructions of healing from one corner of the body to another. When the lymphatic system works smoothly, its presence is subtle, but when it is overwhelmed as during an infection, its activity becomes more noticeable. Lymph nodes swell, not from pain but from preparation. Within them, immune cells multiply and organize. This swelling is not a sign of defeat, but of effort, a calm mobilization, unfolding beneath the surface. And when the immune work is done, the swelling fades, the lymph resumes its slow course, and the body returns to stillness. Tonight, as you rest, this system flows quietly within you, beneath your jaw, behind your knees, under your arms. Lymph moves, slow and clear, visiting each tissue, listening for signs of need. Your muscles, relaxed in sleep, continue to gently encourage this flow. Your breath, soft and rhythmic, propels it onward. There is no rush. The lymphatic system is not hurried. It moves with patience and precision, carrying with it the weightless labor of your immune system, the fragments of invaders, the memory of responses, the potential for healing. And so you sleep, bathed from within by this quiet current, held, supported, and protected not with noise, but with the softest kind of strength. 8. The bridge between innate and adaptive immunity. As the world outside softens into quiet, and your breath becomes gentler still, we now approach a subtle turning point in the story of immunity, the bridge that connects the instinctive to the learned, the immediate to the remembered. In the layered design of your immune system, this bridge is not a structure, but a process, a series of calm exchanges between the innate immune system, which acts swiftly and broadly, and the adaptive immune system, which responds with precision and care. The two arms of immunity do not operate in isolation. Rather, they are deeply intertwined, each guiding and shaping the other. While the innate system is the first to respond, recognizing common patterns and mobilizing early defenses, it also prepares the adaptive system to take over when needed. In doing so, it serves as both shield and scout. This connection is made possible by a group of special cells known as antigen-presenting cells, or APCs. Among them, dendritic cells are the most renowned for their bridging role. They reside in tissues that interface with the outer world, the skin, the lungs, the lining of the gut, ever ready to encounter the new and unfamiliar. When a dendritic cell detects something foreign, perhaps a virus in the respiratory tract or a bacterium beneath the skin, it engulfs it quietly, breaking it down within its internal compartments. From these fragments, the cell selects antigens, small molecular pieces that hold the signature of the intruder. These antigens are then displayed on the surface of the dendritic cell, like quiet flags raised in the wind. Once this display is complete, the dendritic cell migrates. It travels through the lymphatic vessels, moving slowly toward the nearest lymph node. There, within that protected space, it meets naive T cells, adaptive immune cells that have not yet encountered a specific pathogen. The dendritic cell offers its message, presenting the antigen along with co-signals that confirm its importance. This meeting is not forceful. It is a gentle exchange of information. If the antigen is recognized by the T cell's receptor and the surrounding signals are supportive, the T cell becomes activated. It begins to divide, creating a family of cells all tuned to respond to that same invader. Some of these will become helper T cells, guiding the wider immune response. Others may become cytotoxic T cells, capable of identifying and eliminating infected cells. Still, others will become memory T cells, prepared to respond more swiftly in the future. But the bridge does not stop there. The information from the dendritic cell also reaches B cells, another pillar of adaptive immunity. B cells can recognize antigens directly, particularly those that are free-floating or attached to the surfaces of pathogens. But for a full and sustained response, they often require help from T cells. When a B cell encounters its matching antigen and receives assistance from a helper T cell, it begins to transform. It becomes a plasma cell, producing antibodies that circulate throughout the body, seeking out the same antigen wherever it appears. Thus, through the quiet work of antigen-presenting cells, the innate system does more than defend. It teaches. It curates fragments of the world outside and delivers them to the inner sanctum of adaptive immunity, where they become part of a deeper memory. This process is known as antigen presentation, and it is foundational to the immune system's ability to learn and adapt. Without it, the adaptive system would remain dormant, untrained, and unaware. With it, the body gains the power to respond not only to current threats, but to future ones with increasing speed and precision each time. There are several types of antigen-presenting cells, and each has its own rhythm. In addition to dendritic cells, macrophages and B cells themselves can also serve this role. Macrophages, already part of the innate response, can present antigens from the pathogens they consume. B cells, upon binding their specific antigen, can internalize it and display fragments to helper T cells, reinforcing their own activation and guiding the production of more tailored antibodies. All of this occurs not in conflict, but in concert. The innate system surveys and reports. The adaptive system studies and remembers. The signals between them, the cytokines, co-stimulatory molecules, and cellular contacts form a quiet language, learned over millions of years of evolution, honed in every breath and heartbeat. This collaboration is especially evident in vaccination. When a harmless form of a pathogen, or just its antigen, is introduced into the body, it is the innate immune system that first takes note. It engages the antigen, presents it, and calls on the adaptive system to build a memory. Days later, antibodies are produced. Weeks later, memory cells remain, all because of that single shared moment at the bridge. And so, even in this smallest of processes, we see a deeper truth. The immune system is not made of parts, but of relationships. Each cell, each molecule, plays its role not in isolation, but in dialogue with others. There is patience in its timing, balance in its responses, and wisdom in its restraint. As you lie here in the softness of night, the bridges within your body remain intact, connecting instinct to experience, sensation to memory, defense to understanding. The pathways between your cells remain open, their signals clear, their responses precise. You need not feel them to know they are there. You need not act for them to work. Even now, in your most restful state, the dialogue continues: quiet exchanges, soft recognitions, gentle preparations. You are held in a system of care that listens before it speaks, that learns as it protects, that builds memory not from force, but from presence. And so you rest, wrapped not only in sleep, but in wisdom, the wisdom of a body that knows how to adapt, how to heal, and how to remember. 9. The adaptive immune response. As your body melts into stillness and the quiet of night deepens, we now arrive at one of the most remarkable and intricate aspects of the immune system, the adaptive immune response. Unlike the swift generalities of innate defense, this response is personalized, targeted, and shaped by memory. It is the immune system's soft wisdom learned not in haste, but over time, through gentle recognition and careful remembrance. The adaptive immune system is slower to respond than its innate counterpart. It takes time to identify a unique threat, to tailor a defense, and to prepare its forces. But what it offers in return is extraordinary. The ability to remember specific pathogens for years, sometimes for life, and to respond to them with increasing speed and accuracy each time they return. This remarkable response begins with lymphocytes, the specialized white blood cells that serve as the architects of adaptive immunity. There are two main types, T cells and B cells. Each has its own journey, its own way of seeing, and its own role in defending the body. T cells begin their life in the bone marrow, like all blood cells, but their development truly takes shape in the thymus, a small organ nestled just behind the sternum. There, they are educated, tested against the body's own cells, and only those that can distinguish self from non-self are allowed to mature. This process ensures that T cells will not mistakenly attack the body's own tissues. Once matured, T cells circulate in the blood and lymph, quietly waiting. Each T cell carries a unique receptor on its surface, a microscopic key that fits only a specific antigen or molecular fragment from a pathogen. These keys are not forged in response to infection. They are generated randomly, in advance. When a T cell encounters its matching antigen, often presented to it by a dendritic cell or macrophage, it awakens. Some T cells become helper T cells, also known as CD4+ T cells. These are the conductors of the immune orchestra. They do not attack directly, but release cytokines, soft chemical messages that guide and enhance the response. They activate B cells, direct other T cells, and shape the immune landscape. Other T cells become cytotoxic T cells, or CD8+ T cells. These are the quiet eliminators. When they recognize a cell that displays a specific antigen, often a cell infected by a virus, they initiate a gentle process of programmed cell death, or apoptosis. This removes the infected cell without triggering inflammation, preserving the peace of the surrounding tissue. While T cells patrol and coordinate, B cells carry another secret, the ability to produce antibodies. Like T cells, each B cell carries a unique receptor, tuned to a particular antigen. But unlike T cells, B cells can recognize antigens directly without the need for presentation. When a B cell binds its specific antigen and receives help from a helper T cell, it begins a quiet transformation. It becomes a plasma cell, a highly specialized factory for antibodies. These antibodies, or immunoglobulins, are released into the bloodstream and lymph, where they bind to matching antigens with exquisite precision. Once bound, antibodies can neutralize pathogens, mark them for destruction, or prevent them from entering healthy cells. There are several classes of antibodies, each tailored to a different task. IgM is the first to appear during an infection, broad and effective. IgG is more refined and long-lasting, often remaining in the blood for years after an infection. IgA guards mucosal surfaces like the gut and respiratory tract. IgE responds to allergens and parasites, while IgD, though less understood, plays a role in early B-cell activation. Once the infection is resolved, not all lymphocytes fade away. Some become memory cells, long-lived guardians that quietly patrol the body for years. These memory T cells and memory B cells are the hallmark of adaptive immunity. They do not forget, and if the same pathogen returns, they respond more swiftly and forcefully, often clearing the threat before symptoms arise. This is how vaccines work. By introducing a harmless form or fragment of a pathogen, they allow the adaptive immune system to build memory without illness. It is a gentle rehearsal, so that if the real event ever comes, the body is already prepared. But the adaptive system is more than just memory. It is also discrimination, the ability to respond only to what is necessary, to attack only when invited, to ignore the friendly microbes in your gut, the pollen in the air, the gentle tickle of dust on your skin. When working well, it is not only powerful, but wise. And like all wisdom, it grows with time. In early life, the adaptive system is still learning, still building its library of responses. With each new encounter, a cold, a cut, a meal, a breath, the immune system adds to its knowledge. By adulthood, it has developed a rich internal map of what is safe, what is suspect, and how best to respond. As you lie and rest now, that quiet map is active within you. Memory cells stand silently at the edge of your tissues. Antibodies drift gently in your bloodstream, seeking familiar patterns. Helper cells maintain their watch, guiding the rhythm of your immunity. And plasma cells, tucked away in the bone marrow and lymphoid tissues, continue their work crafting molecules of protection, even as you sleep. The adaptive immune system is not swift, it is not loud, but it is enduring. It carries the imprint of your past and the readiness for your future. It works not with panic, but with patience, not with force, but with precision. And so, while the world grows quiet and your body remains still, your immune system remembers. It listens, it prepares, and always, it protects softly, steadily, while you sleep. 10. Antibodies and their calm precision. Let your thoughts grow lighter now, as we drift into one of the most refined and delicate aspects of immunity, the quiet intelligence of antibodies. These small, Y-shaped proteins are the tools of the adaptive immune system, crafted not with haste, but with elegance and intent. Each one is made for a purpose: to recognize, to bind, and to guide, not to destroy on its own, but to point the way. They are the gentle messengers of memory, calm, precise, and endlessly adaptive. The journey of an antibody begins with a B cell, a lymphocyte, trained to recognize one particular antigen. When this antigen, perhaps a protein fragment from a virus or bacterium, binds to the B cell's receptor, the cell is stirred into quiet action. If aided by a helper T cell, the B cell matures into a plasma cell, and its life's work becomes the production of antibodies, molecules perfectly shaped to fit that antigen, and no other. Each antibody is shaped like a soft letter Y. The two arms of the Y are its variable regions, the part that binds specifically to the antigen. These regions are as unique as a fingerprint, tailored to fit the exact structure of a pathogen's surface molecule. This is where the magic lies: an almost endless variety of shapes, crafted by the immune system through genetic rearrangement, ensures that for nearly every possible intruder, an antibody match can be found. The base of the Y, known as the constant region, determines the antibody's class and function. There are 5 main classes, or isotypes, of antibodies, each with its own quiet role in maintaining health and harmony. The first is IgM, the pioneer. It is the first antibody released when a new infection begins. Large and pentagonal in structure, IgM excels at quickly binding to pathogens and activating the complement system, a cascade of proteins that assist in removing threats. Though it is short-lived, it is effective in the early days of response, buying time for more specialized defenses to follow. Next comes IgG, the most abundant antibody in the blood and tissues. It is smaller, more refined, and longer lasting. IgG is often the main defender after a primary infection has passed, and it forms the bulk of long-term immune memory. When you are exposed to a familiar pathogen, it is usually IgG that arrives first, binding with quiet accuracy, neutralizing threats before they gain a foothold. Then there is IgA, found not in the blood, but along the body's mucosal surfaces in the linings of the respiratory tract, digestive system, and reproductive pathways. It is also present in saliva, tears, and breast milk. IgA forms gentle pairs, known as dimers, and acts as a watchful guardian at the entry points of the body. It blocks pathogens from attaching to cells, neutralizing them before they ever cross the threshold. IgE, though present in the smallest amounts, plays a dramatic role in certain situations. It binds to mast cells and basophils, and when triggered by allergens or parasitic invaders, it can initiate a strong inflammatory response. While often associated with allergies, this system once provided vital defense against parasitic worms and other multicellular threats. In many ways, IgE reminds us that immunity is a product of both present needs and ancient encounters. Finally, there is IgD, a mysterious and less understood class. It is found on the surface of immature B cells, where it may help in the early stages of activation. Though its functions are not fully clear, it represents the immune system's depth layers of complexity still being uncovered. When an antibody binds to its antigen, several outcomes are possible. The most direct is neutralization. The antibody may block the active site of a virus or toxin, preventing it from entering cells or interfering with healthy function. Another outcome is opsonization. The antibody marks the pathogen for phagocytes, which more easily recognize and engulf tagged invaders. Still, another effect is the activation of complement, leading to the formation of membrane attack complexes and the clearance of the threat. What is striking about all of this is the lack of aggression. Antibodies do not kill. They guide, mark, and inform. They are gentle hands pointing out what does not belong. They make recognition easier for other immune cells. They focus the immune response, reduce collateral damage, and help ensure that only what must be removed is touched. Over time, as the immune response matures, antibodies evolve as well. Through a process known as affinity maturation, B cells that produce the most effective antibodies are encouraged to thrive. Their receptors mutate slightly, and those with better binding ability are selected. The result is a refinement, a quiet honing of tools, like a craftsman perfecting a delicate instrument. Even after the infection is gone, memory B cells linger. Should the same antigen appear again, they respond more swiftly than before. Some memory B cells reside in the bone marrow, releasing low levels of protective antibodies for years. Others remain dormant, awaiting a signal to awaken. These are the immune system's long-term scribes, keeping a calm, silent record of your exposures. Antibodies also play a key role in passive immunity, the transfer of immune protection from one body to another. This occurs naturally, as when a mother passes IgG antibodies through the placenta, or IgA through breast milk. It also occurs through medicine, such as antibody infusions given to support those with weakened immune systems. In all cases, the principle is the same: to share protection, to offer time for healing, to provide care when the body cannot yet provide its own. And so, as you rest now, countless antibodies circulate within you, tiny, floating sentinels, shaped by your experiences. They do not speak, yet they remember. They do not act on impulse, but with clarity. They are born from encounters, guided by instruction, and refined by time. Their work is constant, but not disruptive. They move with the blood, pause at the tissues, bind where needed, and drift on. They are the immune system's softest voice, calm, precise, enduring. And as you sleep, their work continues unseen, unhurried, always gentle, a symphony of structure and subtlety, playing out within you, in silence. 11. Memory cells and long-term immunity. Now, as the world sinks further into stillness and the rhythms of your body slow into rest, we turn to one of the most gentle, yet profound, aspects of your immune system, the creation of memory. Unlike the rush of first responses or the broad sweep of innate defenses, this is the immune system's quiet reflection, a form of remembrance, subtle and patient, that allows the body not only to survive, but to become wiser with each passing encounter. At the heart of this long-term protection are the memory cells, specialized T cells and B cells that remain after an immune response has ended. They do not patrol with urgency, nor do they attack. Instead, they rest within tissues and lymph nodes, quietly retaining the signature of past invaders. They are, in essence, the immune system's living archive, and they remain poised, should the same threat ever return. The creation of these memory cells begins with the adaptive response. When a pathogen is encountered, naive T cells and B cells become activated. They multiply, differentiate, and mount a response, some becoming cytotoxic killers, others becoming plasma cells that release antibodies. But not all are consumed by this work. A portion of these activated cells are set aside, evolving into long-lived memory cells. Among the T cells, there are two major types of memory: central memory T cells, which reside in lymphoid tissues, and effector memory T cells, which circulate through the blood and peripheral tissues. Central memory T cells are like scholars in a library waiting in key nodes, ready to divide and mobilize when needed. Effector memory T cells, on the other hand, are more like scouts dispersed throughout the body, positioned for rapid response. Should the same pathogen appear again, these memory T cells can react far more quickly than the original naive cells. They do not require the same prolonged antigen presentation or complex activation. They recognize, respond, and multiply, often clearing the infection before it causes noticeable symptoms. The story is similar for memory B cells. These cells retain a record of the pathogen's antigens, the molecular shapes that marked it as foreign. Should the same shapes be encountered again, memory B cells are reactivated. Some become plasma cells once more, releasing large quantities of high-affinity antibodies, finely tuned during the earlier response. Others may continue refining their receptors, becoming even more precise. What makes memory cells so remarkable is their longevity. While many immune cells live for only days or weeks, memory cells can persist for years, even decades. Some remain active into old age, preserving knowledge of childhood infections and vaccines. Their persistence means that your immune system does not start from zero each time it encounters danger. It builds on a foundation. It remembers. This is the principle that underlies immunological memory, and the reason why vaccines are so effective. A vaccine introduces a safe version of an antigen, often a weakened or inactivated form of a pathogen, or just a fragment of its protein coat. The immune system responds, memory cells are formed, and long-term protection is established, all without the risks of illness. In this way, vaccination is a kind of rehearsal. It gives the immune system a first look at a potential threat, allowing it to prepare. If the real pathogen ever arrives, the immune response is already trained, already faster, already more effective. But memory cells are not just sentinels. They are also evidence of how the immune system learns. While innate immunity remains largely unchanged across life, fast, generalized, and constant, the adaptive system is shaped by experience. No two people have the same memory cell profile. Your immune memory is yours alone, the product of your individual history, environment, and encounters. This personal library of memory cells is built gradually. A childhood illness here, a seasonal virus there, a scrape, a cough, a small exposure unnoticed. Each time, a quiet record is made. And over time, these memory cells become the most seasoned members of the immune system, cells that know how to respond, where to look, and what to do. They also reside in places of importance. Some circulate through the blood and lymph. Others settle in tissue niches beneath the skin, in the lungs, the gut, the reproductive tract. These tissue-resident memory cells remain local, guarding the very places where pathogens are most likely to enter. They are not numerous, but they are strategically placed, like gentle watchmen positioned at the gates. Memory cells are also regulated. The immune system ensures that they remain calm until needed. This restraint prevents unnecessary inflammation or misfiring a balance that preserves the body's inner peace. Even in memory, the immune system exercises care. In some cases, memory can fade. If a pathogen is not encountered again for many years, the number of specific memory cells may dwindle. Booster vaccinations are one way to rekindle this memory, reintroducing the antigen so that the immune system is reminded of its pattern and the memory cells are refreshed. But in other cases, the memory remains strong across time, as with certain viral infections, where a single exposure can lead to lifelong immunity. This remarkable endurance speaks to the power of the adaptive system, its ability not only to protect but to retain. As you lie in stillness now, the memory cells within you are quiet. They do not race or stir. They do not act unless invited. But they are present, scattered through your tissues, floating gently in your bloodstream, or nestled deep in the lymph nodes. They hold the blueprint of your past defenses, the echoes of your immune triumphs, and the potential for swift protection. They are not a promise that illness will never come, but they are a reason that illness, when it does arrive, is often milder, shorter, or kept entirely at bay. They are your immune system's reassurance, its silent knowledge, waiting, just in case. And so, in the deep of night, while your conscious mind rests and dreams, the memory of your immune system remains steady. It holds vigil not with anxiety, but with assurance, not with tension, but with calm. Your immune memory is a gift of experience, carefully stored, gently preserved, and offered to you in every breath of your quiet sleep. 12. The complement system and its supporting role. As your body drifts deeper into stillness and the quiet of night wraps around you, we now turn our attention to a lesser-known yet vital ally of immunity, the complement system. It does not act alone, nor does it draw attention to itself. Instead, it works in support, enhancing other defenses, amplifying subtle signals, and assisting in the clearance of what no longer belongs. Like the undertone of a quiet melody, it is always there, softly reinforcing the immune system's harmony. The complement system is a collection of over 30 proteins, most of which circulate silently in the blood plasma, liver-made and suspended in an inactive form. These proteins are part of what is called the innate immune system, but they interface easily with both innate and adaptive responses, forming a seamless layer of immune assistance. They are called complement because they complement the work of antibodies and phagocytes, not by replacing them, but by extending their reach. Activation of the complement system occurs through three main pathways, each one triggered under different circumstances, but all converging to the same endpoint, the gentle clearing of invaders and debris. The first is the classical pathway, which is initiated when antibodies bind to the surface of a pathogen. This binding changes the shape of the antibody, allowing the first complement protein, cone, to attach. From this point, a cascade of reactions unfolds, like dominoes placed in perfect succession. Each protein activates the next, cutting it into fragments that move outward in widening circles of effect. The second is the lectin pathway, triggered when mannose binding lectin, a sugar-detecting molecule, binds to certain carbohydrates on the surface of microbes. This pathway is particularly useful for recognizing bacteria and fungi that lack the outer coverings of human cells. The third, and perhaps the most ancient, is the alternative pathway. Unlike the others, it does not require antibodies or lectins. Instead, it relies on a low-level, continuous process called tick-over, where a key complement protein, C3, spontaneously activates in the bloodstream. If it encounters a healthy human cell, regulators shut it down. But if it lands on a pathogen surface, it binds and begins the complement cascade. In this way, the alternative pathway acts like a soft, ever-listening ear ready to respond to what feels unfamiliar. No matter the starting point, all pathways lead to the activation of C3, the central component of the system. When cleaved, C3 becomes C3A and C3 fragments with distinct tasks. C3A drifts away, acting as a chemotactic signal, calling immune cells toward the site of infection. C3, on the other hand, attaches firmly to pathogen surfaces, marking them for destruction, a process known as opsonization. When a microbe is coated with C3, it becomes easier for phagocytes, such as macrophages and neutrophils, to recognize and engulf it. The cell does not need to guess what is harmful. The complement system provides the mark. Farther along the cascade, complement proteins assemble into a final formation, the membrane attack complex, or MAC. This structure, formed from proteins C5b, C6, C7, C8, and multiple C9s, creates a small pore in the membrane of the target cell. Gently, and without excess, this pore disrupts the balance of fluids and ions, leading to the cell's quiet dissolution. While effective, the MAC is used sparingly. Human cells are protected by regulatory proteins that prevent complement activation on their surfaces. These include CD55 and CD59, which disarm the cascade and inhibit the final attack. These regulators preserve the distinction between friend and foe, ensuring that the complement system remains both powerful and precise. Beyond direct action, the complement system has subtler roles. It helps clear immune complexes, the clusters of antigens and antibodies that form during infection. If not removed, these complexes can lodge in tissues and spark inflammation. Complement proteins help dissolve them and guide them toward removal. It also plays a part in bridging innate and adaptive immunity. When C3 binds to an antigen, it can enhance the activation of B cells, strengthening the antibody response. Certain complement fragments can also influence T cell responses, modulating the strength and character of adaptive immunity. In this way, complement is not simply a background player, but a careful conductor of immune tone, adjusting intensity, supporting clearance, and maintaining peace once the work is done. And like so many immune elements, the complement system is older than we are. It is found in simpler forms in creatures as ancient as sea urchins and lampreys. Its presence across the tree of life is a testament to its quiet utility, refined not by revolution, but by countless gentle refinements. You might imagine, if you like, these proteins as drifting lanterns in your blood, suspended in stillness, but ready to glow at the first sign of need. They do not patrol aggressively. They do not shout. But when called, they move swiftly, illuminating the path for other immune defenders. As your breath becomes deeper and your body sinks into quiet, the complement system continues its subtle circulation. It may not be noticed, even by other cells, until the moment it is needed. And when that moment comes, it acts with speed, balance, and restraint, a helper, a guide, a supportive hand beneath the broader immune system. Even now, the proteins of this system float in your bloodstream, dormant, unhurried, content to wait. There is no urgency here, only readiness, only quiet assurance that the body has what it needs, should it ever be called upon. And so, as you remain in peaceful stillness, the complement system drifts within you, a soft layer of defense, a whisper beneath your immunity, ancient, constant, and calm. 13. Autoimmunity and the balance of self. Tolerance. As night deepens and your mind floats into gentle quiet, we now arrive at one of the most delicate and profound tasks entrusted to the immune system, the act of self-tolerance. In a body made up of trillions of cells, all carrying your unique biological signature, the immune system must not only learn what to fight, but what to spare. It must distinguish, with exquisite precision, between what is self and what is not, between what must be defended against and what must be left untouched. This soft boundary, the ability to recognize the self and avoid harming it, is known as immune tolerance. And when this balance falters, a gentle misreading can occur. The immune system may begin to mistake parts of the body for foreign threats, leading to a group of conditions known collectively as autoimmune disorders. But before we drift too far ahead, let us begin with how the body normally maintains this precious equilibrium. In the earliest days of life, as immune cells begin to mature, the body conducts a quiet form of education. This takes place in the thymus for T cells and in the bone marrow for B cells. Here, developing cells are gently exposed to fragments of the body's own proteins. Those that react too strongly are guided toward apoptosis, a soft and natural form of programmed cell death. This process is known as central tolerance, a first step in preventing self-reactive cells from ever entering the bloodstream. Yet not every potentially harmful cell is caught here. Some escape this early screening, and so the body relies on peripheral tolerance mechanisms that operate outside the central organs, offering a second layer of protection. These include regulatory T cells, or TREGs, which act as gentle moderators. They suppress immune responses that may become too aggressive or misdirected, particularly those against self-tissues. Anergy, a state in which self-reactive cells are rendered inactive, alive, but silent, never fully engaged. Deletion, in which problematic cells are removed through controlled means. Immune privilege, found in certain areas like the eyes, brain, and testes, where immune activity is naturally limited to protect vital functions. All of these processes work together, continuously, silently. They shape an immune system that is alert, but not reckless, one that protects, but does not turn inward. However, in some individuals, this balance can be disturbed. The exact causes are varied and often layered. Genetics, environmental triggers, hormonal changes, and infections may all contribute. When this occurs, the immune system may begin to produce autoantibodies, antibodies that mistakenly target the body's own proteins. Or it may activate autoreactive T cells, which begin to attack self-tissues as though they were foreign. This is the quiet beginning of autoimmunity. There are many forms of autoimmune disease, each defined by the part of the body affected. For example, in type 1 diabetes, the immune system targets insulin-producing cells in the pancreas. In multiple sclerosis, it attacks the protective covering of nerve fibers in the central nervous system. In systemic lupus erythematosus, or lupus, it can affect multiple organs, with antibodies forming against nuclear components of the cell. In rheumatoid arthritis, the immune system focuses on the joints, leading to chronic inflammation and discomfort. Each of these conditions unfolds not as a sudden assault, but as a slow shift, an internal misunderstanding that becomes chronic over time. What is important to remember, even here, is that the immune system is not malfunctioning in a simple way. It is not acting with violence, but with misdirected intent. The cells involved are still performing their designed roles, identifying patterns, responding to signals, producing antibodies, but they are working from a flawed perception. The challenge is not aggression, but recognition. Researchers continue to study how and why this misrecognition occurs. In some cases, a viral infection may resemble parts of the body so closely that immune cells, trained to fight the virus, begin to also respond to the body itself. This is called molecular mimicry. In other situations, genetic variations may reduce the effectiveness of regulatory cells or allow self-reactive cells to survive beyond their screening. Despite these risks, It is worth noting that the overwhelming majority of immune responses in the human body remain properly directed. Most immune cells remain tolerant most of the time, and when autoimmunity does arise, it often unfolds slowly, giving time for observation, care, and in many cases, management. The body also continues to attempt self-correction. Even during autoimmune reactions, regulatory T cells are often recruited, inflammation is monitored, and systems are in place to soften the damage. In this way, the immune system never fully abandons its core mission to protect, to balance, to preserve. Modern medicine now offers many ways to support this effort, from immune-modulating therapies, which aim to recalibrate overactive responses, to monoclonal antibodies that selectively block specific immune signals. But the ultimate goal is always the same: to restore balance, to remind the immune system of its wisdom, to help it see clearly once again. As you rest now, it is comforting to know that within you exists an entire architecture of tolerance, a living, dynamic balance that keeps you whole. Each day, countless immune decisions are made to respond, or to rest, to attack, or to ignore. And most of the time, those decisions are peaceful, measured, aligned with self. Autoimmunity, when it occurs, is not a betrayal, but a gentle confusion, a shift in the internal language of recognition. And yet, even then, the immune system seeks repair, seeks moderation, seeks to return to the state of quiet vigilance it knows best. And so tonight, as your immune system continues its subtle work, know that it does so with care. It watches not only the world outside, but the harmony within. It holds not only the power to defend, but the wisdom to discern. You are, in this very moment, a constellation of tolerance and protection, balanced, aware, and at peace. 14. How the immune system changes with age. As the moon completes its gentle arc across the sky, and your breath continues in soft rhythm, we turn now to the passage of time, not in years or seasons, but within the immune system itself. For just like every organ and process in the body, the immune system is not fixed. It changes, it adapts, it learns, and with age, it moves through subtle transformations, quiet shifts that reflect the body's growing experience and the balance it must maintain. This process of change is known as immunosenescence, the gradual evolution of the immune system over the lifespan. It is not a sudden decline, nor an end, but a reshaping, a rebalancing of energy, memory, and strength. In early life, the immune system begins in a state of exploration. At birth, an infant's immune system is immature. Many cells are present, but they are untested. The first exposures to the world begin a lifelong dialogue. Microbes in the birth canal, skin-to-skin contact, breast milk, and the air itself introduce the immune system to its environment. These early encounters are gentle lessons, slowly teaching the body how to respond. During these months and years, the innate system does most of the work, responding broadly to common patterns, managing small infections, and preventing serious threats. Meanwhile, the adaptive system builds its library of experience. Vaccinations during this time are not just protection, they are invitations to learn. Each antigen introduced through a vaccine helps shape memory cells that may last well into adulthood. As childhood progresses, the immune system becomes more confident. The thymus, where T cells are trained, is large and active in early life. By adolescence, it has already begun to shrink, a process called involution, but by then, it has already shaped a robust population of T cells, many of which will last for decades. Adulthood represents a period of immune maturity. The system is at its most balanced here, trained, experienced, and capable. Most people in this stage experience fewer minor infections than they did in childhood. Memory cells remain vigilant, Antibody production is strong, healing is relatively swift. Yet even during these stable years, the immune system is not static. It continues to learn, adding to its memory with each new exposure. It adjusts to changes in the body, from hormones to stress to environment. It manages the quiet tasks of surveillance, detecting damaged cells, clearing debris, and maintaining self-tolerance. As the decades pass, the immune system begins to shift once again. In later life, especially from around age 60 onward, signs of immunosenescence become more visible. These changes are not dramatic, but they reflect a slow reallocation of immune resources. One of the earliest signs is the continued shrinking of the thymus, which reduces the production of naive T cells, the cells that have not yet encountered an antigen. With fewer new T cells entering circulation, the immune system becomes more reliant on memory T cells. This means it can still respond well to familiar threats, but may be slower or less effective when meeting a new one. B cells also change with age. The bone marrow produces fewer new B cells, and existing memory B cells may become less responsive. As a result, antibody responses can weaken, not disappearing, but becoming less precise or slower to appear. This is one reason why certain vaccinations are recommended or boosted in older adults, such as those for influenza, shingles, and pneumonia, to reinforce protection. The innate immune system also undergoes subtle shifts. While the number of certain innate cells, such as macrophages and natural killer cells, may remain stable, their activity can decline. These cells may become slower to respond or less efficient at identifying threats. At the same time, chronic low-grade inflammation may increase, a phenomenon often referred to as inflammaging. This state is not a true infection or illness, but a mild, persistent activation of immune signaling pathways. Its causes are still being studied, but it may be related to lifelong immune activity, accumulated cellular debris, or changes in metabolism. Though subtle, this background inflammation can contribute to age-related conditions over time. Yet despite these changes, it is important to remember that the aging immune system does not stop working. It adapts, it compensates, it continues to protect, and it still holds memory, sometimes stronger and longer lasting than we might expect. There are also many ways to support the immune system throughout life. Gentle movement, balanced nutrition, restful sleep, and mindful stress management can all help maintain immune function at every stage. These are not cures or interventions, but quiet companions to the body's natural resilience. And it is worth noting that not all immune aging is negative. With time comes experience. The body has learned from every wound, every breath, every passing virus. It has adapted its defenses to suit your life. And in many ways, the presence of long-lived memory cells, the very heart of adaptive immunity, reflects this accumulated wisdom. In the deep of night, the immune system does not see age as weakness. It sees it as history, as a record of all the responses that have kept you safe. It shifts not to falter, but to adjust, not to surrender, but to sustain. And so tonight, whether you are young, aging, or somewhere between, know that your immune system is working in ways large and small, familiar and unseen. It changes because it must, because the world changes, because your needs evolve, and because balance is always being renewed. In the stillness of your rest, your body remembers, it adapts, and it carries you forward quietly, patiently, and with the strength of every year that has come before. 15. How the body ends an immune response. As your body drifts into deeper rest, and the breath settles into a slow and steady rhythm, we now reach a quiet moment in the life of the immune system. Not the moment of first defense, not the height of battle, but the gentle return to stillness. For every immune response, no matter how vital, must one day come to an end. And the way the body achieves this with balance, care, and precision is as important as the response itself. Ending an immune response is not an abrupt shutdown. It is a gradual unwinding, a soft retreat from activity, ensuring that the body heals without lingering inflammation or unnecessary damage. This transition is orchestrated by a collection of cellular signals and feedback loops, each one tuned not to silence but to resolve. Let us begin where the response begins to subside when the threat has passed. Whether the immune system has neutralized a virus, cleared a bacterial infection, or removed damaged cells, the immune cells involved begin to receive different cues. The danger signals, once abundant, start to fade. The body's pro-inflammatory messengers, such as interleukin-1, interleukin-6, and tumor necrosis factor alpha, begin to decrease. In their place, anti-inflammatory cytokines rise. These include interleukin-10, transforming growth factor beta, and other molecules that encourage the system to rest. At this stage, immune cells that were once active start to undergo apoptosis, a soft, programmed form of cell death. Unlike the violent rupture of necrosis, apoptosis is a quiet exit. The cell shrinks, its contents neatly packaged and cleared away by phagocytes. There is no swelling, no damage, no trace of struggle, only resolution. This process prevents the buildup of excess immune cells and avoids the accidental harm that lingering activity could cause. At the same time, specialized cells called regulatory T cells, or TREGs, increase their presence. These cells serve as moderators, calming overly active immune responses and restoring equilibrium. They release suppressive cytokines, inhibit inflammatory cells, and help maintain tolerance to self-tissues. In essence, they help the immune system know when to let go. Other players step forward in this closing act. Macrophages, once fierce defenders, now shift roles, becoming cleaners. They phagocytose apoptotic cells, sweep away cellular debris, and release signals that promote tissue repair. This transition from pro-inflammatory to pro-resolving macrophages is a critical step in wound healing and restoration. In addition, lipid mediators such as resolvins, protectins, and maricins, derived from omega-3 fatty acids, help guide the system toward resolution. These molecules do not simply oppose inflammation, they actively promote its end. They tell immune cells to stop recruiting reinforcements, to cease further attack, and to start rebuilding. This graceful retreat is not passive. It is an active process, requiring coordination and intention, and it is as essential to health as the immune response itself. Without a proper ending, inflammation could linger, damaging tissues, exhausting resources, and even leading to chronic conditions. One way the body ensures this doesn't happen is through feedback inhibition. Many of the same immune cells that initiate a response also carry internal timers, proteins that limit their lifespan or responsiveness. As cytokine levels change, these internal mechanisms trigger the downregulation of receptors, the suppression of activity, and eventually, the cessation of function. Antibodies, too, have a role in closing the loop. Once their work is done binding antigens, neutralizing pathogens, and guiding clearance, their levels naturally decline. Plasma cells that once produced large quantities of antibodies die off, while memory cells quietly retreat into dormancy. What remains is not activity, but readiness, the quiet potential to respond again if needed. This entire process, the shift from inflammation to resolution, is known as immune resolution. It is one of the body's most elegant systems of balance, and while it often unfolds unnoticed, it is the reason we can recover from illness, the reason tissues can heal, and the reason the immune system can remain both active and at peace. Sometimes, however, this resolution can be incomplete. The system may misjudge the moment, fail to clear all signaling molecules, or become trapped in a loop of lingering inflammation. When this occurs, chronic inflammation may develop subtle, sustained, and sometimes harmful over time. This is why the resolution phase is so carefully regulated, and why the immune system invests so deeply in making it complete. And yet, in most cases, the ending proceeds quietly. The storm of activity fades. The redness and swelling retreat. The warmth cools. What was damaged begins to repair. And the immune system steps back, watching once again from a distance. As you lie in the softness of night, your own immune system may be completing this process. A small scratch, now almost gone. A mild infection, already forgotten. Beneath the surface, resolution is taking place, gentle, cellular decisions to return to calm. The immune system does not only fight, it also forgives. It does not only destroy, it also rebuilds. And when its work is done, it lets go, trusting in the body's resilience, knowing that readiness remains for tomorrow. So as you drift deeper into rest, feel this same wisdom within you, the rhythm of engagement and release, of effort and ease. Your body is not always at war. More often, it is healing. More often still, it is waiting, observing, holding its strength in stillness. And now, with the immune system's gentle resolution echoing beneath your skin, you too can settle into safety, into peace, into the quiet restoration that sleep brings. 16. The immune system and the microbiome. In this final stretch of quiet reflection, as sleep surrounds you like a soft mist, we arrive at one of the most fascinating and cooperative stories in all of human biology: the ongoing relationship between the immune system and the microbiome. This is not a story of defense or attack, but of balance, of coexistence, of mutual understanding between your immune cells and the trillions of microscopic life forms that share your body. The microbiome refers to the collection of bacteria, viruses, fungi, and other microbes that live on and within you. They are most concentrated in the gut, particularly the large intestine, but they also live on the skin, in the mouth, in the lungs, and throughout the mucosal linings of your body. They are not invaders, they are residents, and their relationship with your immune system is one of constant dialogue, gentle, complex, and essential. From the moment of birth, this partnership begins. During delivery, a newborn is exposed to the microbes of the mother through skin contact, breast milk, and the surrounding environment. These early microbes begin to colonize the infant's gut, forming the first foundations of the microbiome. At the same time, the immune system is maturing, learning not only what to fight, but what to tolerate. This early contact is vital. Without microbes, the immune system would be understimulated, less experienced, less able to differentiate between friend and foe. And without an immune system that understands its host, microbes might be treated as threats, even when they pose no harm. Instead, the two systems grow together, the immune system shaping the microbiome's composition, and the microbiome shaping immune behavior in return. Nowhere is this dialogue more intimate than in the gut. The lining of the intestine is one of the body's most dynamic immune frontiers. On one side lies the dense population of gut microbes metabolizing fiber, producing vitamins, and breaking down food. On the other side lies the gut-associated lymphoid tissue, GALT, one of the largest immune compartments in the body. Between them lies a thin but effective barrier, a single layer of epithelial cells, covered by mucus, monitored by specialized immune cells. These immune cells do not act with hostility. Instead, they sample microbial antigens in the gut, tiny fragments of protein or sugar from bacteria and food, and present them in lymphoid tissues called Peyer's patches. There, T cells and B cells learn to tolerate most of what they see, Secretory IgA antibodies are produced, not to eliminate these microbes, but to help guide them, gently shaping their behavior, limiting overgrowth, and maintaining harmony. This is how immune tolerance is built. It is not indifference. It is recognition, followed by peaceful coexistence. The immune system learns which microbial signals are normal, which are beneficial, and which should be watched more closely. In doing so, it avoids unnecessary inflammation, preserves the microbial community, and protects the integrity of the gut wall. In return, the microbiome offers profound support. Certain bacterial species produce short-chain fatty acids, such as butyrate, which nourish colon cells and reinforce the intestinal barrier. Other microbes synthesize vitamins like K and 12, or help in the metabolism of complex carbohydrates. Still others stimulate the production of regulatory T cells, supporting immune balance not only in the gut, but throughout the body. This mutual support extends beyond the intestine. The microbiome influences systemic immunity, affecting responses in the skin, lungs, and even the brain. Studies have shown that microbial diversity can shape how the immune system reacts to infections, how it recovers from injury, and how it regulates inflammation. In this way, your microbes become a kind of quiet partner in immune intelligence. The immune system, in turn, carefully manages this partnership. It promotes microbial diversity by supporting a balanced environment. It uses pattern recognition receptors, such as toll-like receptors, TLRs, to detect microbial signals and determine whether they are beneficial, neutral, or harmful. It even allows certain bacteria to live in specialized niches tucked into mucus layers or microfolds of tissue so they can be monitored closely. Of course, this relationship is not always perfect. Disruptions can occur. The overuse of antibiotics, changes in diet, prolonged stress, or illness can disturb the microbial balance, a state known as dysbiosis. When this happens, certain microbes may grow unchecked, while others diminish. The immune system may respond with unnecessary inflammation or lose tolerance to friendly species. In some cases, this can contribute to conditions such as irritable bowel syndrome, food sensitivities, or even autoimmune disorders. But even in these moments, repair is possible. The microbiome is remarkably resilient. With time, nourishment, and care, it can often recover, reseeding itself with the help of fermented foods, fiber, natural diversity, and a calm internal environment. And the immune system, too, remains flexible, always learning, always adjusting, always striving for renewed harmony. Tonight, as you lie and rest, your microbiome continues its quiet work, fermenting, signaling, balancing. Its presence is not felt, but its influence is everywhere. And within the same stillness, your immune system listens. It samples. It learns, not to attack, but to understand. Together, they form a network, not of conflict, but of cooperation. A peaceful ecosystem within your body, sustained by communication and trust. Every breath you take, every bite you eat, every hour you sleep, this partnership continues, unseen but essential. So as sleep deepens now, and your mind sinks further into quiet, feel this balance within you, a living conversation, a gentle alliance between the immune system and the microbial world it protects. You are not alone in your body. You are part of an inner ecology, ancient and enduring, and with every soft breath, that ecology continues thriving, renewing, and holding you in calm. 17. The immune system's role in healing. As sleep draws you further into stillness, and the world outside quiets completely, we now explore one of the most tender functions of the immune system, not to guard, not to remember, not to attack, but to heal. For while defense may be the immune system's most visible role, equally important is its power to mend, to guide tissues back to wholeness, to soothe what has been disturbed. This too is immunity, not just resistance, but restoration. Healing is not a single moment, but a process, slow and deliberate. It unfolds in gentle stages, each one supported by the immune system's presence, not always at the forefront, but never far behind. It begins with injury, perhaps a scrape, a cut, or even a surgical incision. The body recognizes this disruption through molecular signals released by damaged cells. These signals, called damage-associated molecular patterns, or DAMPs, act like quiet beacons. They do not alarm, they simply inform. Nearby immune cells, especially resident macrophages and mast cells, detect these signals and begin the first steps of the healing cascade. The inflammatory phase follows the immune system's careful clearing of debris and pathogens. Neutrophils arrive first, their lifespan brief but essential. They engulf bacteria and release signals to shape the healing environment. Soon after, monocytes enter the area and become macrophages, shifting roles as needed from cleaning to coordinating, from defense to regeneration. These macrophages release cytokines and growth factors, guiding tissue repair. One such factor, vascular endothelial growth factor, VEG, encourages the formation of new blood vessels, a process known as angiogenesis. Another, platelet-derived growth factor, attracts cells that will rebuild tissue. The area, once disrupted, becomes a quiet construction site, overseen by the immune system, managed with care. As the inflammatory phase resolves, the proliferation phase begins. Fibroblasts, specialized cells, multiply and migrate into the wound. They begin to produce collagen, the structural protein that forms the scaffolding of new tissue. This stage is quiet but vital. It is the invisible knitting of the body, the reweaving of skin, vessel, and nerve. Meanwhile, epithelial cells begin to spread across the surface, covering the wound from the edges inward. These cells are also guided by immune signals prompted by interleukins and growth factors to divide, move, and restore the barrier that once kept the inner body safe. Throughout this time, immune cells remain involved. Macrophages, in particular, shift their behavior, transitioning from pro-inflammatory to pro-repair. This subtle change is marked by a different set of molecules, a different rhythm of activity. They begin to encourage anti-inflammatory signals, helping the body move from clearance to renewal. The final stage is remodeling, a slow, lasting phase where the new tissue matures. Collagen fibers are realigned. Excess blood vessels are removed. The scar, if one forms, softens over time. Even now, the immune system is present, ensuring that remodeling proceeds with balance and without overgrowth. This entire cycle, inflammation, proliferation, remodeling, is not just physical, it is orchestrated, shaped by immune oversight. The cells of the immune system do not simply pass through, they communicate, they coordinate, they hold the memory of injury, and then gently release it. Healing is not only for wounds we can see. The immune system also supports the repair of internal tissues, the lining of the gut after irritation, the lung after infection, the muscles after exertion. Even the nervous system, once thought to be separate from immunity, benefits from immune support. Certain microglia, the brain's resident immune cells, help prune neural connections, clear debris, and guide repair after trauma. In the bones, immune signals regulate the balance between osteoblasts, which build, and osteoclasts, which dissolve. In the liver, Kupffer cells, a form of resident macrophage, assist in detoxification and renewal. In the skin, Langerhans cells both protect and heal. Across all tissues, immunity is never just reactive, it is restorative. Even fevers, though often seen as symptoms, play a part in this process. The mild rise in temperature can enhance enzyme function, improve immune cell activity, and accelerate repair. The body knows what it needs, and the immune system listens. As healing proceeds, immune cells gradually withdraw, inflammatory signals fade, growth factors diminish. A sense of calm returns to the tissue. But some memory remains in the form of structural changes, in the presence of protective antibodies, or in the increased readiness of local cells. The area becomes more resilient, more prepared for the future. And so, the immune system does not simply react, it restores. It is not only a shield, but a salve. It supports the body in returning to balance, not only free from harm, but whole once more. Tonight, as you rest in warmth and stillness, your own healing processes may be quietly underway. Perhaps a small cut is closing. Perhaps sore muscles are being repaired. Perhaps unseen tissues are renewing themselves. And behind all of it, the immune system is present not loudly, but patiently, not with urgency, but with care. Let this bring you comfort that within you lies this deep capacity for healing, that even in sleep, your body moves gently toward repair, that within your cells and within your immune system, there is a timeless rhythm, injury and healing, imbalance and restoration, effort and ease. And with every hour of rest, that rhythm continues slowly, softly, and in peace. 18. Closing reflections. A body in balance. And now, as the night stretches on in stillness, and your body lies gently at rest, we arrive at the final chapter in our journey, not a conclusion, but a return to the central truth that has carried us through every breath of this guide, that your immune system, in all its complexity, is a system of balance. It is not merely a defense, it is a conversation, a listening, and a learning, a quiet choreography of cells and signals that allows the body not only to survive, but to live with grace, adapting, renewing, remembering. We have traced its beginnings from the stem cells of the bone marrow to the maturing of T cells in the thymus. We have seen the quiet watch of innate immunity and the elegant precision of the adaptive system. We have observed how antibodies form like tiny keys, shaped to fit only the locks of foreign invaders, and how memory cells quietly retain the lessons of each encounter. We've watched the complement system work like a soft echo beneath the surface, marking, signaling, assisting, and we've reflected on the immune system's most essential restraint, the ability to recognize and spare the self. We've seen how age brings changes, not only limits, but layers of wisdom. We've walked through the gentle winding down of a response, the immune system's return to quiet after the threat has passed. We've entered the realm of the microbiome, where immune tolerance and microbial life coexist, and we've seen how healing, not just defending, is one of immunity's most beautiful roles. And now, with the whole landscape behind us, we simply rest in the presence of it all, because the immune system, at its heart, is not a machine. It is a living intelligence, shaped by your body's needs, your experiences, and the world you inhabit. It responds without pause, but it also pauses when needed. It learns without words. It remembers without a mind. It adapts without asking for attention. It watches, always, but never intrudes unless called. Consider this. Every moment of your life, immune cells are moving quietly through your tissues. Some are stationed in key locations, the lungs, the gut, the skin, while others drift gently through your blood and lymph. They scan, they sense, they wait, not with suspicion, but with care. Their presence is not one of constant alarm, but of steady companionship. Even in sleep, Your immune system does not rest. It rests with you repairing, adjusting, and responding to the quiet signals of the night. It listens to your cells, to your microbiome, to the subtle rise and fall of hormones, and it responds not with judgment, but with balance. It is there when you are ill. It is there when you are well. It is there when you are wounded and when you heal. And it is always seeking one thing: equilibrium. This equilibrium is not static. It is not a frozen perfection. It is dynamic, changing with your breath, your environment, your needs. It allows for strength, but also softness, for reaction, but also reflection. And sometimes, the most powerful thing the immune system does is to do nothing, to refrain, to observe, to tolerate. For immunity is not simply the removal of what does not belong. It is the preservation of what does. It protects the self, but it also defines the self. In choosing what to attack and what to allow, the immune system quietly answers the question, what is me and what is not? This is why it must be so careful. This is why it must remember and forget with equal skill. This is why it holds both sword and salve, both vigilance and grace. And so tonight, as the final hours of rest unfold, you are held by this system, whether you notice it or not. It is not something you must control. It is not something you must fear. It is a gift of nature, refined over millions of years, shaped for the life you live. It will protect you from what threatens. It will repair what is broken. It will let go when the danger has passed. And it will remember, quietly, for next time. You are more than your immune system, but you are never without it. It is not your mind, but it shares in your awareness. It is not your will, but it serves your body's needs with perfect fidelity. In this way, the immune system is a kind of stillness beneath all movement, a quiet companion to every breath, every heartbeat, every moment of existence. So breathe deeply now and feel that presence. Feel the peace of a body that cares for itself. Feel the calm of a system that works in silence. And feel the assurance that, while you sleep, you are protected. You are repairing. You are held in balance. And when the morning comes and the world returns to wakefulness, your immune system will still be there, not asking to be noticed, not needing to be praised, just working, just watching, just being, in harmony